Okay, we will be working on worksheet 14, which is on the trig function of general angles. But first, a little warm-up, special right triangle review. I don't, this is not, wait. Okay, now we did learn about special right triangles in geometry class, so this should be familiar. This is just a proof of that using Pythagorean theorem that if you have a 45-45 right triangle, the legs are some amount, then the hypotenuse is a leg times the square root of 2. We're not even going to be using this immediately, but I wanted to remind you of some of these things. So just quickly, you don't have to write this down. It's not on your paper. So if this was 7, this would be 7, and this would be 7 times the square root of 2. That's how you use the pattern. If this is 15, this would be 15, and this would be 15 times the square root of 2. This one, though, however, is equal to x times the square root of 2 in the pattern. So what we had to do was divide both sides by the square root of 2, and then rationalize it. So you multiply by square root of 2 to top and bottom, and you got 26 square roots of 2 over 2, and then you reduced it and got 13 times the square root of 2. So in this case, the legs would have been 13 root 2, 13 root 2. We're not even going to really have to do these harder kind, okay? But we should know how to rationalize the denominator. If this is 54, maybe you just notice that half the hypotenuse times the square root of 2 is a leg. So for this next one, I would take half of 54, 27 times the square root of 2 would be these legs. Okay, 27. Here, this is 9, this is 9, this is 9 root 2. 18, 18 root 2. Okay, that's 45, 45, 90s. Then there was the 30, 60, 90. And the short leg was x, the long leg was x times the square root of 3, short leg times the square root of 3, and the hypotenuse was 2x. And if it went this way, it's still the same thing. This was x, this was 2x, the hypotenuse, and the long leg was x times the square root of 3. Now, I'll bring this up again when we get to it. So there's the pattern. This is just some ways to think about it. I'm not going to need to do a ton of icky ones of these, but if you knew the hypotenuse was 16, the short leg would be half of it, 8, and this would be 8 root 3. If the short leg's 37, the long leg's 37 times the square root of 3, the hypotenuse would be 2 times 37, so it would be 74. Okay, I think that's enough on that. Let's get to what we're doing today. And I'll come back and revisit those patterns a little bit later. Okay, so trigonometric functions of general angles. If you let theta be an angle in standard position and let P a point be x, y on the terminal side of theta, then the Pythagorean theorem, r equals the square root of x squared plus y squared, would give you the length of that hypotenuse, if you will, right there. The 6 trigonometric functions of theta are defined below. These are just different ways of saying opposite and hypotenuse, etc. It's on, you notice that r is the hypotenuse. This would be your reference angle. And these pieces, this would be like your y, and this would be like your x. Okay, or it is. So I'm going to draw a bigger one of those. Thank you. So over here, let's just make a big triangle. And I'm going to put theta here, which is the reference angle. We're going to, remember I told you last week that reference angle can be denoted by theta with a little hat on it, or this means, or you can have a tick mark on it. Those stand for the reference angle. So if this was the picture, your little right triangle would have been here, and this would be x, this would be y, and this would be r. So we're just giving another definition for sine, cosine, tangent, and its reciprocal functions, cosecant, secant, and cotangent. The sine is y over r, opposite over hypotenuse. Get used to it that way, but you want to start thinking y over r. Cosine, adjacent over hypotenuse, x over r. Tangent, y over x. And cosecant is the reciprocal of the sine, so it'll be r over y. Secant, reciprocal of the cosine, so it's r over x. And cotangent is the reciprocal of the tangent, x over y. I really don't have, so what you need to memorize, you need to memorize or know these because we already got it down that these are the reciprocal of those, right? So we're going to find all the 6 trigonometric functions of theta if the point on the terminal side of theta is 512. So I'm going to make a little sketch of that. So I'm going to say 512, 512, so it looks something maybe like that. Now, this point is 512, and then if you drop a perpendicular to the x-axis, the y part would be the vertical part, so that would be 12, and the x part would be the horizontal part, so that would be 5. We need to figure out r. We know x is 5, we know y is 12, and now we need r. So r squared would equal 5 squared plus 12 squared. And that would give me r squared is 169. And take the square root, and we've got r is 13. Now, I wrote more than you may have needed to write, okay? But I wanted to remind you that we're doing Pythagorean theorem. From now on, I'm going to do the square root, r equals the square root of x squared plus y squared, okay? Now, this is 13. We just figured it out. My pen is stuck. There we go. So we could cut it down here, or you could put it on the picture. It depends on the person, what they prefer. Of course, if you have the picture and you're thinking about theta being right here, the 6 trigonometric functions of theta would be, you could still do your opposite over hypotenuse kind of thing, or you can remember that's y over r, so it would be 12/13. The cosine would be adjacent 5 over 13, and the tangent would be 12/5. The reciprocal functions cosecant would be 13/12, secant 13/5, and cotangent 5/12. So for number 2, if I make a little picture, 3, 4 is also in the first quadrant. 4 would be the vertical number, 3 would be the horizontal. Let's find r. And theta is always with the origin and the positive x-axis, or the x-axis in anywhere else in the other quadrants. So right now, it's in quadrant 1. So we do r equals the square root of 3 squared plus 4 squared. So r is going to be the square root of 25, which is 5. So now you've got x is 3, y is 4, r is 5. Sine is y over r, so 4/5. Cosine, x over r, 3/5. And tangent, y over x, 4/3. The reciprocal functions, just flip over the fractions. Make sure that these are in the order, though. Sine and cosecant are reciprocals, so 5/4. Cosine and secant are reciprocals, 5/3. And tangent and cotangent are reciprocals. Anybody still need this? No? Good. Number 3. If I were to draw this, where is it? Well, 8, -15 would put me in quadrant 4. Right 8, down 15, looks something like that maybe. Drop a perpendicular up to the x-axis. Your reference angle theta would be here. And the vertical number is -15, that's your y. Your x is 8. And we need to find r. So r, I was about to do r squared. I'm going to do r equals the square root of 8 squared plus -15 squared, which would be positive. So that's square root of 289. And so r is 17. So we got x is 8, y is -15, and r is 17. Sine, y over r, -15 17ths. 8 17ths for the cosine, and -15 eighths for the tangent. And then I'll just write my reciprocals. This doesn't get icky until we start getting some radicals. Here it comes. Okay, so we've got x is -8, y is 12. Let's find r. Negative 8, 12 would be left 8 up 12, so we'd be in quadrant 2. Always need to be able to identify the quadrant you're in. Okay, so negative 8 and 12 is your vertical. If I do my Pythagorean theorem, I would have r is the square root of 64 plus 144, which is 208. Square root of 208, I need to simplify that as a radical. So I got to figure out what perfect square number divides into 208. Okay, now I know 4 would, right? 4 goes into 20 and 8. You can tell it's divisible by 4. So I would try 16 to get a bigger one possibly. And that's the one because it's 16 times 13. 4 square roots of 13 is the r value then. Okay, so these are going to get a little messy. Now, what I suggest you do, and I wish these blanks were separated a little better, is just write them. Don't rationalize them right away until you do the reciprocals. Okay, then go back and rationalize any that you should. All right, so the sine y over r, so I've got, oh, I'm going to put that down here. 12 over 4 root 13. Well, what could I do to that? Yeah, it reduces, right? So 4 goes into 12 3 times, so that'd be 3 over the square root of 13. Now, let's go ahead and write the reciprocal function, the cosecant. So let's flip it over. Square root of 13 over 3. And now rationalize it, because I've already used it. I don't want to rationalize it and then try to flip it over. It would be a mess. Okay, just make more work for yourself. So to rationalize this, we multiply top and bottom by the square root of 13, which gives me 3 square roots of 13 over 13. Does anybody not know where I'm getting this from? I can show how I got 3 square roots of 13 over 13. Yes, no? We're okay? All right. Please don't hesitate to ask if you do need it. Cosine of theta, x over r. So that's going to be negative 8 over 4 root 13. So I'm going to think about that. Divide top and bottom by 4 would give me negative 2 over the square root of 13. So I'll flip that over now, be negative square root of 13 over 2. Your negative sign should be out front, not in the denominator. And the tangent is just y over x. So it's 12 over negative 8, which we should reduce to 3, negative 3 halves. So cotangent would be negative 2/3. Maybe still need this? That does say negative 3 halves. I don't like my negative sign. It's kind of connected to my equal sign. There. Any questions? Yes. Oh, I didn't finish the cosine. Thank you. Yes, ma'am. We got to rationalize this one. Negative 2 root 13 over 13. Thank you. I forgot to rationalize my cosine. Yes. No radicals in your basement. 5. Okay, so I've got negative 9 for x. I've got y is negative 40. Figure out r. And the calculator, I'm going to do 9 squared because I don't feel like doing the negative sign because I'm going to square it anyway. 9 squared plus, was it 40? Okay, so I got, 1681. I'm hoping that's a perfect square. Second, x squared, put in that answer. And bingo, yes, 41. A Pythagorean triple. Okay, careful with your signs. So sine theta, oh, I didn't draw where this is. What quadrant are we in? Yep, 3. You got negative 9, negative 40. I know these aren't to scale. And not that you have to draw it. You do not have to draw it. I just thought it's easier for some kids to get used to why it's y over r. So negative 40 over negative 40, 41st. And then I'm just going to do the reciprocal real quick. Cosecant would be negative 41 over 40. Cosine's negative 9 over 41. Cosecant, negative 41 over 9. And the tangent, 40 over 9. It will be positive because a negative divided by a negative is a positive. Cotangent will also be positive. Okay. And number 6, x is a 1, y is a 2, r is a square root of 5. I got that very quickly because 1 squared plus 2 squared is 1 plus 4. Okay, we're in quadrant 1. And we got the square root of 5 for our hypotenuse. So sine is 2 over the square root of 5, which gives me cosecant square root of 5 over 2. I'll go back now and remember to rationalize, and I get 2 root 5 over 5. Okay. For my cosine, I have 1 over the square root of 5, x over r, and the secant would be the square root of 5. If I rationalize my cosine, I'll have the square root of 5 over 5. And the tangent is 2 over 1, or just 2, and the cotangent is 1/2. So far, so good, I hope. Little Pythagorean theorem, really. And remembering your trigonometric ratios. Something to talk to you about, quadrantal angles. We want to know what the sine, cosine, and sine and cosine are of these. So I'm going to jot down, oh, it's not theta, excuse me, I want to write the number of the degrees in here. So we're going to do sine of 0 degrees. And right now, since we're doing the y over r and x over r thing, let's look at what they've got written down for the point there. Sine is y over r. 0, so the radius basically is equal to the x component here. That's what they're saying. That's why it's r0 for a point. Now, since sine is y, x, sorry, I wrote the wrong thing. Here, y equals 0, x is equal to r. With me? And r is itself. R equals r. All right, so if you were going to do the sine of theta, it would be y over r. 0 over r would give you 0. Anything divided by 0 is 0. I mean, 0 divided by anything. I've said that opposite of the way I meant to. Anything, 0 divided by any number is 0. Now, the cosine would come out to be x over r. Our x is an r. R over r would give us 1. So I'm going to tell you that here, the answers are going to be 0, 1, or negative 1. That's it. Or possibly undefined if we were doing the tangent. Let's do the sine of 90 and the cosine of 90. If you go to 90 degrees, which is here, or pi over 2 radians, sine is, remember r is r. You got r for y equals r this time, and x equals 0, and r equals r. So sine would be r over r, which is 1. Cosine would be 0 over r, which would be 0. Okay, next, 180. Sine of 180, cosine of 180. Now we've got negative r over 0. So the sine is y over r. Y here is a 0. X is negative r, so it's going to be 0 over r, which is 0. Okay, cosine 180 will be x over r, so that's going to be negative 1. Okay. We could. We'll go back and do it if you like, because we're gonna have to start learning exact values today. I'll go back and do tangent in a minute. All right, let's continue with this. These are either 0, -1. So we got sine 270. These are the quadrantals and the cosine of 270. All right, you're at 0, -r. R over r would be -1, and the other one would be 0. Cosine would be 0. Okay, so I was asked to look at the tangents there. Sure. Tangent is 0 degrees, and I wrote a theta. Tangent would be y over x 0 for this one, and you can just look at these even. The tangent of 90, if you did it, would be y over x. R over 0, that's undefined if you get 0 on the bottom. And the tangent of 180 is y over r, so that's going to be 0. And the tangent on 270 is going to be undefined. Okay? You asked, you got it. 0 or undefined are the possibilities for the quadrantals. If you were going to do your cotangent, the reciprocal of undefined is 0, and the reciprocal of 0 is undefined, if you will. Okay, so we already did, now, reference angles. I already mentioned what a reference angle was. Let's make a little bow tie to remind you. So I'm going to make my little quadrant, my x and y axis, excuse me, and then I'm going to put on there, I feel like using color, so I'm gonna, oh, where'd my segment tool go? Guess I could have gone, okay, so I'm gonna make the bow tie to show you where these reference angles are. Your reference angles are always with the x-axis. Remember that this means reference angle. And let me explain why that is. In the first quadrant, your reference angle is theta. In the second quadrant, though, your angle theta is actually bigger than 90, and it's terminating in quadrant 2. So the reference angle is rather here. That's the reference angle. The angle actually was from here to here. Okay. In the fourth quadrant, the reference angle goes there. And did I say third? I thought it came out of my mouth possibly fourth. So it was in the third quadrant. And the fourth quadrant is here. I'm just making the bow tie so you remember where your reference angle should be. Okay, always with the x-axis. Now, what this is talking about here is to figure out what your reference angle is. You do the following. If your reference angle or your angle's in quadrant 1, it's itself. If you go to quadrant 2, what you need to do to figure out this number is to take 180 minus theta. Or, if it's in radians, pi minus theta. If your angle terminates in quadrant 3, you're going to figure out this number right here. So you got to take off 180 from the angle. That's why it's theta minus 180 or theta minus pi. Because 180 is either pi in radians, and in degrees 180. 360 degrees is way over here. So if you land in quadrant 4, you need to take theta away from 360. Okay? Now I'll show you. It'll make sense just by looking at the different pictures we'll draw. Okay, so we're going to draw the angle, and then we're going to figure out the reference angle. Okay, so we came and we say, remember, all your angles start with the initial side is the positive x-axis. So 135 is going to put me in quadrant 2. The rule said if you land in quadrant 2, then you're going to do 180 minus theta, which is 180 minus 135, which gives you 45 degrees. So your reference angle is 45 degrees. The answer is 45 degrees. For 200 degrees, we will always start with the positive x-axis. We're going to go 180 and then how much more? And the how much more is actually your reference angle. That's why the rule in this quadrant is to do your theta minus 180. 200 minus 180 gives us a reference angle of 20 degrees. That would be the angle right here. 5 pi over 3. Uh-oh. You could. So right now, with what we know, we're going to memorize this one, though, eventually. We'll know where it is. 5 pi over 3, I'll just say, is close to 2 pi. 6 pi over 3 is 2 pi. This thing's going to terminate in quadrant 4. So let's see. I'll show you why. You're going to know that better in a short amount of time. Let's convert back to degrees. The only problem is, guys, our answer must be in radians. The reference angle has to be in the same units as what you started with. Okay, so 5 pi over 3 times 180 divided by pi. That would be the conversion, way to convert it to degrees, which we discussed last week. You cancel out your pi's. 3 goes into 8. 180, 60 times. 5 times 60 is 300. All right, so 300 degrees. That means our 5 pi over 3 is in quadrant 4. Like I thought, but then I've had experience with this. This is 5 pi over 3. It's not degrees. But what would the reference angle be in degrees? Okay, 60. So I can show you 2 ways to get this answer. One, we need to convert it back to radians. So you would multiply by pi over 180, which actually gives you pi over 3. The other way is, knowing that we terminated in quadrant 4, if you look at that chart, the rule said do 2 pi minus theta. 2 pi minus 5 pi over 3. Okay, if you were going to do that, then you would have to get a common denominator, multiply by 3, which gives you 6 pi over 3 minus 5 pi over 3, and that is pi over 3. Okay, so we could have just done that, but then you might not have known where it was because this didn't mean a lot to you as far as what quadrant it would land in. But once I teach you the unit circle, you're going to know which quadrant that's going to land in. You'll know because 1 pi over 3, 2 pi over 3. Anyway, I'm going to explain a whole pattern for how to figure it out. All right, but anyway, regardless, the answer is pi over 3, not 60. Okay, now I've got a mnemonic for you because who wants to memorize and write that down, right? Looks kind of yucky. All right, so if you're taking this class, chances are you're planning to go forward with your math, which means you may end up taking the big calculus, right? Calculus. Anyway, this says all, and by the way, this is only for the sine, cosine, and tangent. My mnemonic only works for those. Then you need to understand that they would have the same properties as their reciprocal function. All we're doing is deciding whether it's positive or negative in each quadrant, okay? So all students, and I'll write this down here. All students take, that would stand for your tangent, which implies the cotangent. And these imply each other, being all positive. All students, what's positive in quadrant 2? Sine and cosecant. That's where the S stands for, is the sine. T for tangent. That's what's positive in this quadrant. The rest of them are negative. Okay. And calculus is the last. All students take calculus, and that's not spelled right. Yes. All right, so C for cosine. That implies the secant is also positive. All right, so that's the one way to remember which of the trig functions, what their sign, positive or negative, is in each quadrant. Find the exact value of each trigonometric function. Use special right triangles. All right, here we go. 150. First, let's figure out where it is. Make a little sketch. Think about 150 up. It's not going to hit 180, so it's in quadrant 2. Figure out your reference angle. What would the reference angle be? 30 degrees. Okay. Now, I'm going to look at that as a special triangle. But I think it might behoove me to draw it a little bit better. So that's because it's not really to scale. So if you have a 30, 60, 90, this would be 60 up here. Now I want the exact trigonometric, the exact value. I do not want decimals. You can't push these on your calculators. Just forget about even opening it up. Okay? Opposite over hypotenuse is the sine. Well, let's make the opposite leg be 1. What would the hypotenuse be in the 30, 60, 90 pattern? It would be double that, so it would be 2. So this would be, the sine would be opposite over hypotenuse, 1/2. 150 has a sine of 1/2. Now, if you put the square root of 3 here, because that's what it would be if it was for that special right triangle. If the short leg is 1, the hypotenuse is 2 times it, and the long leg is 1 times the square root of 3. You see how you can get the sine, cosine, and tangent for 60 and 30 off this triangle? They're all there. Okay? The cosine of 30 would be square root of 3 over 2. You with me? The tangent of 30 would be 1 over the square root of 3, and you have to rationalize it. All right, cosine 270. Oh, hey, wait. Where's that? Well, that's a quadrantal. So what we're going to do when we do a quadrantal is we're going to make the radius, this length, be 1. So if that was 1, what is the x value? Like, name this point. Name that point the simplest way you can. 0 for x, yep, 1 for y. You can't make a triangle out of this. There's no triangle, right? There's no reference angle. It's a quadrantal. So now you say it's y over r. What's r? 1. Okay, see how I'm making a circle, sort of? It's part of a circle. So if I say cosine is adjacent, or x over r, it's going to be 0 over 1, which is 0. Okay. X over r would have been 0 over 1. Cotangent, 135. Well, why we didn't do 135 yet? Okay, so that's halfway into quadrant 2, which gives me a reference angle of 45. Which means I have a 45, 45, 90. Now I'm going to make these legs be 1. Oh, but that would be left, so it would be -1 and +1. Now, the hypotenuse, or radius, if you will, is always positive, all right? So if you were to take and do the Pythagorean theorem, 1 squared plus -1 squared is going to give you 2. Square root of 2 would be the hypotenuse. That's your 45, 45, 90 pattern. So I'll remind you of that again. In a 45, 45, 90, the legs let be 1, and the hypotenuse will be the square root of 2. That'll help you get those trig functions every time for this reference angle. All right, so what's the cotangent? Well, the tangent would be opposite over adjacent, so it'd be -1, and the cotangent would also be -1 because it's just -1 over 1. It's still -1. Tangent of -30. I'm not going to write so big. I don't need a ginormous set of quadrants. I know that's going to be in quadrant 4. And that would be a reference angle of positive 30 degrees. Reference angles are always positive angles. But negative 30, that's where it is. It's down from the x-axis, which would be the same as negative 330. I mean, positive 330 degrees would be coterminal with that. Okay, so I'll make this opposite short leg 1. The long leg would be the square root of 3. Hypotenuse would have been 2. So using special right triangles, the tangent is y1 over x square root of 3. Hey, wait, is any of these positive, negative? Any values in quadrant 4 negative? Okay, this one will never be negative. It's always, the radius is always positive, R for radius, okay? You got to know if x and y are negative or positive. Okay, so this would be opposite over adjacent, negative 1 over the square root of 3, but I got to rationalize that. So that's going to be negative square root of 3 over 3. I kind of wrote on top of some of my notes here. Hold on. That was negative 1. Okay, negative square root of 3 over 3 is the exact answer. Tangent of 4 pi over 4. Now, you're saying, whoa, how am I supposed to know this? Well, I think you need to memorize that pi over 4 is 45 degrees reference. It's equivalent to 45 degrees. It's in radians for 45. Anything with a something pi over 3, that's a reference of pi over 3, and you want to know pi over 3 is 60 degrees reference. Cotangent, well, you know, pi is 180. And anything pi over 4, again, is 45 degrees. So I'll prove this to you and show you what I'm talking about. Here we go. Tangent of pi over 4. Pi over 4 is in quadrant 1, halfway. Its reference is 45. If you wanted to convert, you could do your conversion factor. Well, actually, we need to memorize this. You need to know pi over 4, period. You need to know pi over 3. You need to know pi over 6, okay? Pi over 4, 45 degrees reference. That would give you a 45, 45, 90, and the tangent here would be positive 1. Cosine 4 pi over 3, we might want to figure out what quadrant we're in by converting right now because we don't have this thing, the unit circle done yet. So that's going to be 180 divided by pi. 60, that's 240 degrees. Okay, so where we are is quadrant 3. We're in it 60 degrees. Okay, that means my reference was pi over 3. So now that I know I'm in 60 degrees, I'm going to think special right triangles and think 30, 60, 90. A short leg, negative 1. Yes. Why wouldn't it be what? This is 180. Okay. Yeah, because here's this halfway is 180. And then, so I do 240 minus 180. All right, now I got my short leg, negative 1, because it's left in the quadrant. And this is negative also. Negative square root of 3. That's their long leg. I didn't draw it very well to scale for you, but opposite the 30 is the short leg. Opposite the 60 degrees is the long leg. All right, so we're going to have, we're trying to do cosine, and the hypotenuse would be positive 2. They're always positive there. So if we're doing cosine, that's x over r, so negative 1/2. Cotangent, negative pi. The negative pi is going to be going down and to here. Okay, so negative pi would be the same as positive pi, understood? All right, which is what degrees? Let's get that memorized. Halfway? 180. All right, so you don't need to write 180 because we're doing in terms of pi. But we got cotangent, and what is that? Well, let's think of a point here. X would be negative, so negative 1, 0 would be a point on that terminal side of theta. And that's going to give me cotangent. I need to think tangent is y over x. So cotangent is x over y. It's negative 1 over 0. Can you do that? That's when you write undefined. UND. Or undefined. Okay, negative 3 pi over 4. Guess what the reference is? Just think for saying what I've said so far up here. It'd be 45 because it's, you see pi over 4, it's just 3 of them, okay? So it's going to be 40. Did you check it out for the decimal or the degrees? It is negative 135 though, right? So that means you're going to be in quadrant 3. Okay, now. So I guess I could have said, look, 1 pi over 4, 2 pi. Oh, never mind. 2 pi over 4. I'm going to teach you that later. All right, we're at negative 135. So reference was 45. We're trying to find the sign. And that we're in quadrant 3. Therefore, these are negative 1 and negative 1. And this is the square root of 2. So it's going to be sine negative 1 over the square root of 2. Got to rationalize that, so that's negative square root of 2 over 2. That's our answer. Okay, we will be discussing the unit circle going forward, and this will start to get easier as we do that.